Hi, my name's Stuart Lynch. In this video, I'd like to take a closer look at how you can capitalize on and craft some really effective and useful view modifiers in SwiftUI. We're going to take an incremental approach, but by the end of the video, you should have 3 view modifiers that you can start using today. I have a starter project for this video, and I recommend that you download it from the link in the description. It's a starter project branch for this project that contains the starter application that we'll be working on. There's also a completed source code branch as well that will contain the completed source code, but I recommend that you work along with me as you'll gain a better understanding if you do that. So just download and expand the zipped archive from the starter project. What I want to do in this video is to show you how you can incrementally improve on custom view modifiers that we'll create to make your code more readable and flexible. We'll be creating 3 of them in this video. And as I go through each one, I'll explain the starter project. So right now we have this navigation link that takes me to a second view by pushing the view onto the navigation stack. So let's go to that second view now, and we see that it's a very simple view. All it contains is a content unavailable view. Now, because this is being pushed onto a navigation stack by that navigation link, we mustn't embed this view in a navigation stack because it's already in one. This means then that we can add a navigation title to this view. But when we do that, we don't see that in the preview because it has no idea that it was being pushed onto a stack. I'd really like to see what it looks like inside a navigation stack. So typically what one might do is to embed the preview inside a navigation stack. Now the preview knows that it was pushed onto a navigation stack, so this is what it'll look like. I can see by returning to content view that when I reach that second view, the title is displayed. Rather than doing the full embedding in the view, what I prefer to do is to create a view modifier that I can apply to whatever view that I want. I have a full video on creating view modifiers, so if you have not watched that video, I recommend that you do. A link is in the description. So I'm going to create a view modifier for the purpose of embedding views inside a navigation stack. So I can avoid doing that in a preview. So I'm going to create a new Swift file, and I'm going to call it custom view modifiers. View modifiers are SwiftUI, so I'm going to change the import to SwiftUI. And I'm going to create a new struct here for this first view modifier, and I'm going to call it InNavStack, and have it conform to the view modifier protocol. To conform to that protocol, we'll need a function called body that has an argument called content that is of type content. And this is just a type alias for whatever view is passed into the body function. And that is whatever view we want to apply the modifier to. And this will allow us to make some modifications to that content and return some view. So if we're going to modify that content, that's what we'll start with. Well, since we're going to be passing the entire view, that is what our content is, we can embed it here within the navigation stack. Now our objective here is to be as swifty as possible. So since this is a view modifier, we create another function that is an extension on the view type itself. I like to call the function the same as my view modifier, but start with a lowercase. And for this function, it's going to also return some view. Now, since this is an extension on view, it means that the function is being applied to self, which is a view, and a view has a modifier function that will accept any view modifier. So we're going to pass in the one that we just created. Now, since it is, again, an extension on view, this self is actually redundant because what else could it be? So I can remove it. So we can apply this now. I'm going to return to that second view, and I'm going to remove that navigation stack embedding here. And instead, I'm just going to apply the InNavStack view model. And when I do that, you see that we have exactly the same thing. Now, if I return to the content view, I can see that the navigation links still work, and I can see our view has that navigation title that we specified. I hope you're enjoying this video, and if you are, please give it a thumbs up and leave me a comment. It would also really help if you could subscribe to my channel and enable notifications so that you're alerted when I drop a new one here on YouTube. I put out weekly videos and I seldom miss a week, so if you really want to support my work, you can buy me a coffee. A link is in the description. Notice, however, that when I tap on the toolbar button here, that same view appears, but this time it's as a modal sheet, and there is no navigation title. I'd really like to have my cake and eat it too, though. I want to see that navigation title here as well. Well, I can, just here where I'm presenting the second view, apply that same modifier here. This view modifier allows us to make changes to the view with view modifiers outside of the actual view itself. The other thing we can do if we want to apply a navigation bar title display modifier of inline before the navigation modifier, we can do that here. This is about as simple as a view modifier can get. So let's take a look at a second example. Well, taking a look at this view here now, it looks like our view only has a text field here. And when I tap in it and start to type, however, I see that the text is also entered below it. And I can also see that the text field has a vertical axis that will expand. But the second display actually scrolls, and that's because it is a text editor. And I could type here too, and because I have bound both views to the same state property, both are updated. If I go to my code now, I can apply a text field style view modifier to the text field, and I see that I've got three choices, one of which is a rounded border. And when I do that, I see that it encloses that text field with a rounded border around it. So let's try that with the text editor. And I'm going to apply the text editor style, but I see now there are only two options, automatic and plain. There is no rounded border. Let me option click on the text editor style, and I can go from there and open the developer documentation. And then I can drill down on the text editor style where I see there is actually a rounded border style. However, if I click on the rounded border, I see that it is only available to Vision OS. I do see, though, that there is a text editor style, but there is no information provided on the text editor's style configuration, like we would see for a button style configuration or a label style configuration. So it seems like I should still be able to create a custom text editor style of my own, but there is no details here on this configuration. So it seems like it's half-baked. So for this, then, I'm going to revert to just creating a view modifier. So in our custom view modifiers file, I'm going to create a new struct called text editor style that conforms to the view modifier protocol. As usual, this is going to require a function that is the body function that will receive the content and return some view. What I'm going to do then with this content is I'm going to overlay this content with a rounded rectangle and a corner radius of 5, which is what it looks like the text field border radius is. But I'm also going to set a stroke where I'll attempt to match the color of the text field. And for this, I believe the color is pretty close to the UI color System Gray 4. And I'll set the line width to 1. Then I'm going to create another extension to view with a lowercase function using the same name as my style. That's going to return some view. And then I can apply to self the view a modifier passing in our text editor style. And make sure you choose the one that is not the built-in one. We want the one that is our text editor style. If I return to content view now, let me change it from this plain to just the text editor style. And this now switches to our view modifier. Well, this looks pretty good, But you'll see that there are actually two issues here that I think I can fix. If I type into either field, the text field or the text editor, I can see that the padding is different between the two. For example, if I type my name is Stuart Lynch, the app developer, I can see that the wrap is different. And the padding vertically is more in the text editor than it is in the text field. I'd like to match them as closely as possible. Now, in order to check what that padding should be, I use a tool that I got from my Set App subscription that's called Pixel Snap. If you aren't a Set App subscriber, I really recommend that you do. I have no association, no affiliate to it, but I still really recommend Set App for getting all sorts of useful developer tools. Now with this, I can zoom into my view so that I can see a little closer. And then I can invoke the crosshairs that will allow me to discover the distance from the border to the top of the letter M in each case. And I can see it's different from each. It's 15 pixels from the top of the first text field to the letter M, but it's 21 for the text editor. And I can similarly discover the distance between the leading edge and that letter. So as I said, I'd like to match these as closely as possible. So I'm going to go back to my view modifier, and using a lot of trial and error, I came up with these edge insets that I can apply as padding to the content. For the top, I need to move it up, so I'm going to set it as a negative 4.3. For the leading, I found 1.2, 0 at the bottom, and for the trailing edge, 1.2. Now, if I return to my view and enter that same string, it wraps nicely and things seem to line up properly. So let's switch now to dark mode. And I'm then going to zoom in. And I can see that the border around the text field is much fainter than the text editor. We're not adjusting to the environment. So I'm going to return then to the view modifier. And then I can use the environment to access the color scheme key path to create a color scheme variable so that I can verify which of the color schemes I'm in, either light or dark. And if I know that, I can adjust the color of our stroke based on that color scheme. So if the color scheme is light, we know that it's okay, but then we can use a ternary operator to provide a dark mode alternative. And for my testing, I think it's pretty close to the System Gray 6 UI color. Well, it's not perfect, but it's better, as we can see in our content view. Let me switch back to light mode. There's one more thing though. The text field style allows me to specify a static text field style of rounded border, and I'd like to mimic that here as well. Well, the text field style also has a plain and automatic, which in iOS is the same thing. So I'm going to do the same thing for my text editor style. And I'm going to create an enum called style with 3 cases: plain, automatic, and rounded border. And then I can create a property called style that I can pass in when I want to create or use this modifier. So within the body then, I'll check to see if the style is equal to rounded border. If so, then I'll return the content as is with those modifiers applied to it. Otherwise, I'll just return the content and leave it alone. And since I added a new property to the text editor style, I'll need to add that to the style parameters for my view extension function, which is of type TextEditorStyle.style enum case. Now, I don't want to have to enter the label though, so I'm going to place an underscore in front. The modifier though itself requires a label though, but we'll still be using this function instead. So let me return to content view, And now I can pass in the rounded border case as the argument. If I switch the argument to plain, it's removed. Now you may want to go back and make some adjustments to the line width here. It looks a little thick, but I'm going to leave that up to you. Now there's one thing that you might consider. This is a view modifier, and it can be applied to any view because it is a view extension. I'd really like to restrict this only to text editors. So if I return to my view modifier, I can change this extension for a view to be the extension to a specific type of view, and that's a text editor. Now, if I return to my content view, and if I tried to apply this text editor style of any rounded border to the button, I'd get an error saying that it's unavailable in iOS. So it looks like it's trying to use the built-in text editor style. My view modifier is not even an option. On now to our final example. Sometimes, as a design requirement for our apps, we want to change the entire background view for our SwiftUI views from this light or dark color, depending on the color scheme, to something completely different. And for that, a technique that is often used is to embed the entire view inside the navigation stack, in this case, in a Z stack, and then provide a color view as the first item in the Z stack, like red. Then have it ignore all safe areas. And you might even want to apply an opacity to that color to tone it down a bit. Doing this, though, reveals that I have a problem with my text editor modifier. This border is inside the top of the text editor view. So let me quickly go back and fix that. I'm going to return to my view modifier, and what I need to do is to add a corner radius to the content itself that matches the overlay one of 5. If I return to my content view now, I can see that all is good. Anyway, what I want to do now is to relieve me of the burden of having to embed my views in a Z stack and add a color background as the first view in the Z stack. That's what a view modifier can do for us. And I can embellish it to give myself more options. First though, let's create the view modifier for the color. So this should be pretty routine now. In our custom view modifier file, let's create a new struct and call it with background view and have it conform to the view modifier protocol. And as usual, provide the body function that we can get access to the content to apply our modifiers to. Well, that content is what we're passing in, so we'll embed it in a Z stack. And then as the first element in the Z stack, I'll create a color view, and I'm going to use the color red, and I'll apply this on an opacity of 0.3. And I'll have it ignore all safe areas. Once more then, I'll create an extension on view. And inside there, I'll create a function called with background view, with the lowercase first w, that will return some view. And then to self, I'll apply the modifier that uses our new view modifier. So I can return to the content view now. I can remove the Z stack and the color view from there, and instead simply apply the modifier to the V stack. And I can go to the second view and apply that same modifier to that view. Quick and easy. Now we have that red with the opacity 3 background throughout. Well, what if I want to make this even more generic and more flexible? And I want to be able to use any color, pass in with or without opacity. Or perhaps I want a UI where I have a linear gradient background or a mesh gradient background instead. But I want to use the same view modifier for all 3 cases. As examples, I've created some sample backgrounds here, and they are included in this project. As you can see, I have an enum namespace with two static properties. One's a linear gradient, and the other one is a mesh background. What I'd like to do is to provide our users with the ability to use a color, a linear gradient, or a mesh gradient. So colors are easy, but I provided these two samples for the gradients to speed things up. Back in the view modifier, then I want to create an enum for the three different cases of color, linear gradient, and mesh gradient, but I'd like to provide each with an associated value. So I'm going to create an enum called background type. Now the first case is going to be a color where the associated type is color. The second case will be linear gradient, where the type is linear gradient. And the third will be mesh gradient, where, you guessed it, the type is mesh gradient. Well, now we can add two more properties to our view modifier. One for the background, that is going to be one of these background type cases. And the second one is going to be opacity, which is a double. So we can specify what the opacity is for any of those three cases. So in the Z stack, instead of this fixed color with fixed opacity and ignoring safe areas, I'm going to replace it all with a switch statement on the background property and let Xcode generate the cases. It even gives us the variables for the associated values. And this is going to be whatever we want to present. So we can just simply use those variables as our content. Now for whichever one is chosen, I'll need to apply the opacity and set the ignore safe area to, but I can't do that in a switch statement. So I'll need to embed it within a group. And then I can apply opacity, providing the double value that's being passed in. And then I can apply the ignore safe area. We'll need then to add those two parameters to our view extension function. So I'm going to use an underscore for the background so that I'm not going to have to use the background label. And its type is going to be a with background view background type. And then I'll need to supply an opacity, which is a double, but I don't always want to supply a value, so I'm going to set a default value of 1.0. And then I'll have to update our modifier itself to pass in those two corresponding parameters. So we can see that our current view modifier is broken. So let's remove it from the second view and come back to content view first and test out our new version. The modifier name is still with background view, but it needs at least the background property because remember, I provided a default value for opacity. So let's use the color case for the background type. And this is going to require an associated value that is a color, so we could supply red. And this is too bold, so let's apply as well an opacity of 0.3 like before, overriding that 1.0. So let's change this to a different type of background. Let's choose the linear gradient case. So that's going to require us to supply a linear gradient. Well, I have that static sample background linear gradient. That is a linear gradient. So it goes here from red to white from the top to the bottom. And I'm going to leave the full opacity here because I think this is okay. And finally then, let's try to apply a mesh gradient case and provide one as the associated value. And again, I provided that sample, and it simply sets a different color to each of the four corners, namely teal, purple, indigo, and green. Again, this might be a bit bold, so let's add an opacity property here. And this time I'm going to specify 0.5 to override the 1.0. This looks pretty good. So I'm simply going to copy this modifier here and go to my second view and apply it there too. I can see now that I have a nice mesh background on both views. So this has been 3 different view modifiers created to make your life simpler and your UI better and easier to implement. I hope you found this video useful and you will be encouraged to start using view modifiers more in your own projects. View modifiers are not project dependent. I can take this file of view modifiers that I've created now and use them in any of my projects. If you found this tutorial helpful, please give it a thumbs up and leave me a comment. You can subscribe to my channel to get notifications of new videos, and remember that you can also download my YouTube channel listing app for free and quick access to all of my 350 plus YouTube videos. A link's in the description. And also remember I have a full SwiftUI course available on my Teachable site where you learn how to build a fun multi-targeted app.